All right, then, let's continue with the effects of the climate crisis, as promised. So, some of these are more obvious than others, but we still need to ensure that we're on the same page. So the threats without any government intervention, well, first and foremost, there is the human cost. The increase in mortality that we're already seeing, and morbidity, so the prevalence of diseases among the general population, caused by crop failure, air pollution in particular, and the various sort of facets of the climate crisis, will, of course, cost lives, but also reduce the ability to work and earn an income. Right? So even if you're not exactly dying, but you find it harder to work, harder to land a job, and then harder to earn an income, that will have devastating economic and social consequences. Then there's the more direct economic costs. Well, you're simply allowing, if without any government intervention, the destruction that is certain to take place, that's already taking place due to extreme weather events, whether it be bushfires or hurricanes or flooding and so on. Now, looking at the effects on distribution, so there's no doubt that the poor will continue to be hit hardest as they have the least ability to adapt to climate change. And with that come the effects on demand that we've already noticed or noted in this course, namely that the poor have a higher propensity to consume, so a reduction in income can only lead to a reduction in demand. So that is a macroeconomic problem in itself. Unemployment caused by forced migration, which is sure to have short-term effects on the amount of people out of work or looking for work. Not to mention the hysteresis effects of the destruction of jobs in the carbon-based industries. So in particular, what we see, what is meant by hysteresis is the idea that as, let's say, a miner is left unemployed after the mining of coal and oil and so on is wiped out, if they are especially older workers, it will be very hard for them to find a job in a new sector, a new perhaps high-tech sector, if they don't have the training and experience in that sector. And so this sort of transition can lead to unemployment which is stubborn because those people who are unemployed find it hard to enter a new, very different sector. This is long-lasting damage, this hysteresis. Okay. With regards to inflation, well, there's a potential, at least, for rising energy costs as the world makes a slow transition to new forms of energy. Depending on exactly how that transition is made, it could mean that energy costs go up. And if energy costs go up, then, of course, prices will follow. More, perhaps, relevant and more important is the threat of instability. So in particular, what we see with the climate change debates is the idea that as the world makes or is meant to make this transition to a non-carbon based economy, you have all this wealth that is tied up in the holding of, let's say, oil companies and so on, which is based on the reserves of oil, gas, and coal, which can no longer be tapped or should no longer be tapped if we are to ensure that we don't exceed the targets set in the Paris Agreement and other international treaties and so on. So this is what's meant by the carbon bubble, is this overestimation of the value of wealth linked to or backed by carbon-based assets. So just to go into a bit more detail on this, because it's, I find, very interesting and quite a large threat. Even in the face of government intervention, if it's not done correctly, you could still have a massive financial crisis. Because, according to a study published in Nature, a third of oil reserves, half of gas reserves, and over 80% of current coal reserves need to remain unused from 2010 to 2050 in order to meet the target of 2 degrees Celsius as agreed upon in the Paris Agreement of 2015. Now, this is the upper limits, right? The lower limits is 1.5, and this is perhaps garnered more consensus in the scientific community as the sort of real limits before a runaway climate change scenario. But anyway, 2 degrees, and we still need to keep this amount of oil and gas and coal in the ground which of course is in sense keeping wealth in the ground as we currently understand it. That means that the assets backed by fossil fuels, like shares in Shell and ExxonMobil and so on, are likely significantly overpriced. So we have two problematic scenarios. Oh, there's a bit of a formatting error here, but never mind. So one is that carbon companies pursue measures to ensure no climate policy takes place, and this is the thing we've already considered, the lobbying and the disinformation of those corporations to ensure no effective action on the climate takes place. Or even if action does take place, it renders tens of trillions of carbon wealth worthless. Right? And with that comes the usual financial crisis followed by an economic crisis. So any government intervention needs to recognize and mitigate the threats of the popping of such a carbon bubble, as necessary as it may be. So, in that sense, or with that in mind, let's ask the question, what can we do, recognizing these threats to the economy and to society and the environment? Well, so in this course, we have used the circular flow model repeatedly. So let's bring that thing up again. Here we have it. And we're going to throw it away because it's absolutely not going to help us. Because, of course, as I said in the introduction, we have, simplified and used this abstract concept of an economy that's just floating in space, which is of no use to us now as we try to understand our relation to the environment and the interaction between the environments. In particular, every act within the economy is based on the energy that comes into the earth and what we do with that energy to manipulate materials and so on. So we're really ignoring the energy and material aspects of the wider circular flow, which is, the sun giving us energy into the earth, and we're using that to manipulate the materials already found here. And so this monetary circular flow model is not going to be much use to us right now. Instead, at least for considering the broad aspects of climate change in an economic setting, we can use Kate Raworth's donut model, which has gained some popularity in recent years. And although it's somewhat limited in its policy prescriptions and so on, or at least its predictive power, let's put it that way, it's a good starting point. And basically all Raworth is saying here is that you have limits to growth. On the one hand, or limits to let's say, the income level, if it's or our use of resources. If our use of resources is too small, then we fall below this inner ring here, the social foundation, right? And this is the level of resource use needed in order to ensure that there's enough water, food, education, health, for everyone, such that social harmony is present and we have peace, justice, and equality, and so on. So this is the social foundation. And as long as we don't fall below that, we can ensure a certain level of justice and so on. However, if we push it too far, then we exceed the ecological ceiling on the other side. And this is obvious in the context in which I'm introducing it. This means, growing so fast that we cause runaway climate change, or the acidification of the oceans, or, the loss of biodiversity and air pollution, whatever dimension you want to look at. So what Raworth is saying here is that there is a Goldilocks zone, if you like, the safe and the just space for humanity. It's regenerative and it's distributive, right? And finding that sort of Goldilocks zone is the key then for policy. So how do we ensure we don't break through this ecological ceiling? Well, broadly, we can consider the following variables, right? Our impact on the environment is a function of the population of the globe, the affluence of the globe, and the state of technology. And this is an idea that goes back to the 1970s. Unfortunately, I can't remember the authors behind this very simple equation, but we can discuss it in the reading group. So these three variables in particular will affect how much of an impact we have on the environment. And it should be pretty straightforward why that is the case. Population, of course, affluence. Technology, well, because depending on the state of technology, we may be able to reduce the emissions per unit of energy or electricity created out of whatever resource. But let's put this in more specific terms. And this is what the Kaya identity does. It kind of takes this idea and makes it a bit more specific. So here, P, we have population. G, we have GDP of the globe, and P is population of the globe. F is the emissions of CO2 caused by humanity. E is the energy use or energy consumption around the globe, and that's all our variables. And as you can see, it's an identity. That's a misspelling, of course. It's an identity whereby, really realistically, if you just cancel it all out, it would just say, F is equal to F. But, it's a kind of decomposition exercise, which allows us to examine our intuitive notion that, well, our carbon emissions are based on GDP per capita, energy intensity, so for every unit of outputs in GDP, how much energy do you need? And the sort of carbon footprint of the energy that you use. So it's a decomposition. And it allows us to consider, how we don't break that ecological ceiling, right? So, for example, let's take population. Well, one way you could say, okay, if we want to minimize our environmental impact, we can slow down population growth. Right. Difficult. Is this possible without dictatorial means? More than that, the rate of growth of population around the world is already falling and is expected to peak by the end of the century. So, at least in theory, it would be a way of reducing the environmental impact. In practice, extremely difficult and perhaps highly undesirable. What about if we try to reduce the energy intensity, this one here, E over G, and carbon footprints of the energy that we use? Well, this is often the way out, the answer to the climate change puzzle put forward, especially within the mainstream. And you can't deny that it would be helpful. It is especially reliant on technological progress in the right areas. And currently, as we can see from data on CO2 emissions and so on, it's not swift enough at the moment. With that in mind, given that the private sector, the market as it is not bringing about CO2 reductions quickly enough, it seems to imply that government investment and intervention is strongly necessary in order to reduce these variables and therefore reduce the environmental impact. There is, however, especially within the ecological camp of economics or macroeconomics, the concern about rebound effects, which makes technological change less effective than hoped. We're going to go into what exactly this means in the next slide. Then, of course, there was the last idea based on this simple identity that, well, in order to reduce the environmental impact, we can reduce GDP per capita or the GDP growth rate. And then we enter the debate on whether policy should therefore be aimed towards green growth or degrowth, as we will define them in the next slide, bar 1. So the rebound effect. What is the rebound effect? It is a reduction in the expected gains from new technologies that increase the efficiency of resource use because of behavioral or other systemic responses. Now that might seem like a mouthful that isn't very intuitive. Let's put it in context, and then we'll go through this equation. So suppose you've got a new car, and the car fuel efficiency goes up 5% through technological change, but you end up reducing your fuel use by only 2%. So in some sense, you're increasing your fuel use after the increase in efficiency. So that leads to a 60% rebound effect. What does this really mean? It is essentially saying, well, the car fuel efficiency has increased by a certain amount, and because of that, it's cheaper to go each mile in fuel. So therefore, you go further, or you drive faster, which actually increases your overall fuel use, right? Yeah, it increases. Yeah, yeah. So therefore, we have this idea of the rebound effects. So you have the expected benefits, which is in this case an increase of 5%, which would be the case, would be the outcome if we hold our consumption of this particular good, in this case, driving, the same. But we have then a loss in the benefit because we actually change our consumption. We actually increase our driving because of the change in car fuel efficiency. So that's how we get to this estimate, or this calculation of the rebound effect of 60%. We have the loss benefit, which is 5 minus 2. That's the loss over the expected benefit of 5, which gives you 0.6 or 60%. So usually we expect the rebound effect to be between 0 and 1. So it's not that we have no change in consumption, although perhaps sometimes we will, so that it will be 0. But we have somewhere in between, so a partial rebound. However, if we have a rebound effect greater than 1, then we have what's called Jevons paradox. And Jevons was one of the first sort of neoclassical economists, but he wrote on the subject of coal and our use of coal as a sort of powering of the economy. And he noticed that as the steam engine became more efficient, it just simply led to more factories making use of the steam engine to such an extent that any gain in efficiency of the steam engine was virtually wiped out by the increased use of steam engines and coal to fire those steam engines. So that the rebound effect is greater than 1, where actually the better technology, put bluntly, or to summarize it, the increased technological power simply leads to more emissions of CO2, or the more use of coal in this case. What is a proposed solution to deal with the rebound effect? Can we always just accept that technological progress will come with perhaps more emissions than we would hoped? Well, a proposed solution by Wackernagel and Ries in the Journal of Ecological Economics is to say, well, any cost savings that you get from efficiency gains, so in the example of the car, as it becomes cheaper to drive a mile, you should tax, in this case petrol, more, so that the price that the consumer faces actually doesn't change. So they don't change their behavior. So as the price comes down, you tax it higher, such that the price actually ultimately remains the same post-tax. And that increase in revenue you can then use for aims such as rehabilitation of natural capital forests and other parts of the environments and so on, or funding renewable investments and so on. So this is the rebound effect, and here is already one way of thinking about how we can mitigate the problem considered in the rebound effect. What is meant by the debate between green growth and degrowth? Well, to summarize, degrowth economists typically tend to think, well, economic growth and environmental protection are simply incompatible, at least in industrialized countries. Whereas the green growth camp, which is more of a mainstream perspective, say, well, the two objectives are compatible. In fact, environmental protection measures can even work to stimulate economic growth, both in the short term and long term. So there's more than a compatibility, there's a sort of suitability. The debate is far from any conclusion. The debate rages on. However, just to offer some subjective thoughts on what's going on here, because ultimately there's a lot of questions about exactly the terminology used and what is meant by these terms, and there's a lot of technical questions that need to be answered that we don't quite have the answers to. But at least some subjective thoughts at this point. Well, if an objection of green growth is growth through the greenest means possible, that would seem to miss the point, right? Because if it's still growth, which is the ultimate goal, then we have to accept that even if it's more efficient in terms of energy usage, that's not quite what we need. That's still going to make the problem worse, albeit at a slower rate. and we need to be working the opposite way. However, to kind of ask a question of the degrowth side, well, if an objective of degrowth is economic contraction, even at the cost of less investment in, say, carbon-free technologies, that also seems to miss the point. So, for example, and this is purely a thought experiment, if fusion were possible tomorrow, where you have clean energy, let's just for the purpose of this thought experiment say completely clean energy, low cost, available to everyone. Now, this would 100% completely lead to an increase in GDP. Now, should we castigate that increase in growth as somehow problematic? Well, not necessarily. Now, some within the degrowth community would say, well, that will come at the expense or use of more materials. This is why the debate is messy and so on. And they would say, well, there's a limit on materials and not just on CO2. Well, that to me at least seems to be a different problem, but it's a debate really worth reading into and worth having, more than I'm presenting here at least. In any case, let me just say that the fetishization of growth is damaging, and this seems to be common to virtually every economy out there today. The idea that growth and the growth rate of GDP is the one indicator of health of the economy and social welfare. That's a really outdated idea, and I think that's broadly held in consensus amongst all economists. Yet it still remains the indicator of well-being. Instead, we should aim for a broader array of environmental and well-being indicators. So we should certainly, at the very least, be growth agnostic, because we've already gotten to a point where growth, at least in the industrialized world, really does not seem to have much relation to well-being. After you get past a level of, let's say, $20,000 per person per year in income, the increases in growth don't seem to have any strong correlation to increases in subjective well-being. What can we do about the climate crisis? Well, I guess there's more of a mainstream idea, but it still holds. There are some low-hanging fruits, so to speak. Namely, there are some investments, there are some activities that actually have a negative cost, because in order to say, retrofit insulation in your own home or in commercial units and so on, that will reduce the amount of energy you consume and electricity you pay for in your bills and so on. So that investment actually brings a monetary gain. And all of these are examples of abatements of CO2 that lead to financial reward. Then we get to the other side of this abatement curve, which perhaps has a positive economic cost, but would still be worthwhile undertaking in order to address climate change and reduce CO2 emissions. And there's some ideas here like, nuclear, for example, and so on. I won't go into every one of them, but I'll leave them there for you to see. Concrete measures, healthcare is particularly important when we think of climate change, because especially when we regard air pollution, it is one of the leading causes of death around the world, and also disease, as we see here for data in, 2017. For the risk of death, air pollution, outdoor and indoor, is the fourth highest factor behind increases in mortality rates. And in the morbidity rate, on the other hand, it's also around fourth, it's fifth, right? So if government healthcare initiatives can reduce the amount of air pollution, we are very likely to see an increase in the human capital of each economy. So people can go out and work and put their skills and knowledge to use to expand the economy and increase welfare, of course. We also have to keep in mind that there's going to be an asymmetric effect on different parts of society as we transition to a renewable economy. So just to put some numbers on what I mean, here for the US, we see that 1.1 million people work in the industries of coal, oil and gas. In Poland, there's 140,000 that work in mining, and in Germany here, it is 50,000. Now, if we were tomorrow to just move to a new economy with none of these industries, of course, all these people would be unemployed, and that is not what we would like to see in terms of a just transition. Why should these people be punished for the old setup of society and how it sources its energy? So government policy must keep in mind, construction of new renewable energy jobs, but also, in particular, to combat that issue of hysteresis we mentioned, that we should have retraining schemes for these displaced workers, and not simply say, well, the market will fix these things. Of course, some people will simply not have the money to enter education again, or won't know exactly what they should be doing in terms of education. So finance and advice in that regard for those people left behind is crucial to allow for a harmonious transition. With regards to fossil fuels, how they're currently priced, this is one of the perhaps biggest absurdities with policy around the world, is the level of subsidies that are currently leveled on fossil fuels. So, a study from the IMF in 2017 found that fossil fuel subsidies around the world amounting to around 5.2 trillion US dollars. That's around 6.4% of global GDP. They found, or they concluded, that ending subsidies would cut global emissions by a quarter and early deaths or premature deaths by half. And here's the graph in that publication. What we see is a difference between pre-tax subsidies and post-tax subsidies, and this distinction is very important actually for the meaning of subsidies as the IMF have used it here. Pre-tax subsidies, here in orange, in absolute value on the left in terms of billions and percentage of GDP on the right. Pre-tax subsidies mean what we would usually think by the term subsidies. It's money given directly to energy providers, who use fossil fuels. Whereas post-tax subsidies, this kind of really takes into account the idea that those who produce electricity, or let's say electricity using fossil fuels, pollutes the atmosphere at no tax rate. They are not priced, or there's no cost to pollute directly into the atmosphere. And therefore, this is an instance of market failure, which only benefits them, those companies, and obviously comes at the cost to society as a whole. So if you were to price that in, of course, it's substantially higher. So we have a very perverse setup. Still, in 2020, the International Institute for Sustainable Development had a report where they looked at how those subsidies, the pre-tax subsidies, so the lower amounts here, could be used to pay for a global transition, and said, well, even 10, perhaps 30% of pre-tax subsidies could be used to actually push the economy, the global economy, along the way to that 1.5 degree target. So with the idea that there's simply not enough money in the economy, there's simply not enough revenue to pay for these measures, it's an absurdity, because we're already paying so much for these subsidies, whether it be directly or indirectly. And reduction and the redirection of these subsidies would surely help a great deal, as is outlined many times in the literature. But we must keep in mind that if we are to increase carbon taxes to correct for this instance of market failure, then the tax revenue that is brought in must be used to compensate for the higher prices that are inevitably caused when you introduce new taxes, especially on fuels and so on. At the same time, it would make a lot of sense if you're increasing carbon taxes, let's say on fuel that most people need, then you're going to need to compensate perhaps in reduced consumption taxes on everyday goods and so on. And in particular, I mean, this is with keeping the yellow vest movements of a few years ago, I guess in some sense still ongoing, in mind, because of course they eliminated the wealth tax in France and introduced a petrol or fuel tax during a time of austerity, and naturally people across France and then other parts of the world were very upset. So it's not enough simply to increase carbon tax. Getting towards the end of our lecture here, of course, green investment is an extremely important part. We've seen that the the markets, the free markets, is not very good or is not moving with the sufficient degree of haste towards green investments. So there's a massive role for government investments, especially in low carbon infrastructures. And here we're thinking in terms of the electricity transmission grids that are already in public ownership in most cases, or electric vehicle charging facilities. Retrofits are particularly important for publicly owned buildings, but also perhaps providing incentives for commercial and private use to private retrofits backed by government funding. And research development is, of course, perhaps a good use of public funds in this regard. There's also been ideas about green quantitative easing. That's in the Fermos et al. Paper. I won't go into too much detail, but we're using a lot of quantitative easing that props up the financial sector, and it could be used perhaps to some good in aiding the transition. We've already mentioned carbon taxes, and we won't go into differential capital requirements, but we can discuss it on Thursday if you wish. To finish, of course, with any notion that government should spend a lot more comes the all too frequent criticism that such a high level of public debt is simply not sustainable, is not viable. However, and this is a fundamental point which requires its own lecture, which will be the subject of next week, so I'll reserve 99% of what I have to say until then. But for now, let's just keep it relevant to climate change and say, well, if we fail to act today and say, well, we don't want to leave the next generation with higher debts that they must pay off, then we also fail to recognize that the cost of not acting on those future generations is massive. So it's just not the same problem as other sources of public debts, because that cost will be left to them whether we do anything or not. And here we have some very rough measures. I normally dislike these sorts of world clock kind of dramatic things, but it serves the purpose here to show that the cost of not acting goes up with every day of inaction, as does the world temperature and as does the rise in sea temperatures and so on, sea levels. So the public debts will rise, but that is also not necessarily, and in fact is not, the problem that it is often made out to be, as we will discover in greater detail next week. Okay, that's all I have to say for this week. There's a lot of information. Unfortunately, I still think that within macroeconomics there's not a sufficient pedagogical framework to unite all the different aspects of climate change. It has improved over the years, but it's still quite not there. So there is a lot of information to deal with here, but of course it is the most pressing issue of our time that affects every economy. And so it must nonetheless be included, at least in my view, on any sort of half-useful course on international economic policy. So I hope you enjoyed it, and I very much look forward, as always, to discussing these ideas with you on Thursday. Okay, I will see you then.